by adding this reaction module, we could then take the IPs of the participating bots, give them to the Nordsam project, and then they could, at all participating firewalls, just block all these bot IPs. So this has two implications. First of all, if you're getting DDoS and already blocking all bot IPs anyway, it's more the upstream provider which gets DDoS and not yourself anymore. And the other thing is, there is some internet sites which are using this who have rather large traffic, and users of infected computers cannot access these internet sites anymore because they're firewalled from them, and that makes them feel like my computer is broken, I need to find someone who repairs it, so hopefully the machine gets somehow disinfected. The ASN mail reaction module just sends a mail to the ASN of the command and control server, so we run an whois on the IP and try to find some abuse information or whatever, and also mail neighboring ASNs, so we hope that this way the command and control server gets somehow taken down. Yeah, of course, now that we are all tracking these commands, we also want to log them. We log them to files into our own IRC control network, or also into a Postgres database, which again allows for great correlation. And yeah, this is a brief schematic overview of this little piece of software. I'm sorry I don't have a demo available again because it's not my laptop. But how do we now mitigate botnets? This is the shortest part of the presentation because it's one of the least researched parts. The simple thing is we change the DNS entry of the command and control server to some other IP address, like loopback. But this has three problems. First of all, we need to convince the DNS provider that this is a bad thing, and there's huge amounts of DNS providers in Russia and China who say they pay, I don't care what they do. The second thing is it has to rely on DNS anyway. If it's using static IP lists or even a peer-to-peer botnet, this cannot harm the botnet at all. Yeah, these were 2 in 1. So if it's peer-to-peer, it doesn't work because it's not centralized, and if it's not using DNS, it doesn't work because, yeah, well, obviously. Then what we can do for us, if we don't have contact to a DNS provider or whatever, we could, if we're a university or whatever, we could block all traffic to the command and control IPs to at least protect the students at our university. The most, or the best approach is just take down the CNC server, so we try to contact some law enforcement agencies in the countries of the CNC servers. Well, there's not only DNS providers, but also server providers in Russia and Romania especially. And law enforcement in Romania doesn't seem to care too much. Perhaps it changes after they joined the European Union, but I doubt. So we need the cooperation of these people, and they say, botnets, what is that? Or botnets, yeah, well, but they are attacking your country, why should we care? Or they say whatever. So this is hard to do. And all these three have the problem. If it's a peer-to-peer botnet, there's no central instance we can take out. Yeah, so these will probably fail as well. So what's our conclusions? Yeah, our honeypot-based techniques can help us to learn more about botnets and autonomous spreading malware, so we can collect it. Then we have to analyze the malware, and then we can efficiently find new botnets without having the need to have an infected computer at our own network. And so we can do local and global mitigation. But we need more research, we need more time, and we need more help, of course, because we want the zero-day vulnerability support, and we want more people just like tracking botnets who are willing to spend their free time on contacting law enforcement agencies. Although the Shadow Server organization, which can be found at shadowserver.org, is doing a pretty good job on this. Yeah, and of course, the more sensors for malware we have, the more malware we have to analyze, the more botnets we can find. So if you would join the MW Collect Alliance, that would be really helpful. Yeah, and that's it. Got any questions? Yeah, that either means my presentation was really bad or really good, so no questions? One question?
Oh, sorry. So more and more malware is starting to detect virtual machines. I mean VMware and virtual PC and stuff like this. And how do you try and how do you analyze this kind of malware? Because this is, I think it will be a very big problem in the future because...
Yeah, this is now, it's getting more and more. So the question was, if I understood it right, how do we detect malware, or how do we analyze malware which detects the presence of a virtual machine? Well, the most simple answer is we have one physical machine dedicated for this, which is using a hardware restore PCI card, which restores the hardware on each reboot. But this is slow because we need to reboot the physical machine. So if we... and this one needs to be activated manually, so it's not in the automated process. But as we see the threat emerging, that because it's more and more just packers which already include the detection mechanism, we are currently working on writing our own virtual machine as well, which already includes the analyzation software, which also has some other implications, as we don't need to run the whole operating system anymore, just the malware in this virtual machine. But as you might know, writing a virtual machine is not such an easy step, so this is part of ongoing research. I'm also doing this for my company and not as open source, so I cannot talk too much about it. But if you can feel free to come to me later if you want to know more about this. So yes, it's a great problem that there's, they are adding VMware detection, but we also have QEMU, and I've not ever seen a single piece of malware which is running QEMU detection. The backside again is QEMU is slower than VMware, and well, this is the thing which is just emergent, and we first have to see how hard it would impact our research. Any other questions?
Shouldn't you be helped by the new KVM in the Linux kernel with QEMU, because it's really fast now, because it uses the new virtualization in the AMD and Intel processors?
Yeah, it's not, well, so the question was on this QEMU, right?
No, there is KVM.
Ah, okay.
It's in the latest kernel, and there are models for the older kernels, and it's a virtualization, and it uses a forked version of QEMU for using Windows on it.
Yeah, that might be another thing we should look at. So it's called KVM?
Ja, KVM, also V auf Deutsch.
Klar, okay, Dankeschön. Well, if there's no more questions, thanks for your time, and I'm also open for questions now in private here.